simplifying, this is 3-6, simplifying rational expressions. So the goal here, the directions for all these problems is going to be, of course, to simplify. But the thing is that you must always factor first before you can cross anything out. So one of the things in the that you did in the activity today is you were looking at 4x over x, and you compared it to 4 plus x over x. So let's compare with these two. So in this case, you are allowed to cancel. X over x becomes what? It just simplifies to 1. You can cross them out. And the answer is 4. But here, and I'll try to use a different color or red or something, or this, you cannot cancel the x's. So it would be, that would be wrong. So would you please write wrong? Because, simply because it's not equal to 4. I mean, you could try plugging in a number and you can see for yourself. Let's try 1. Let's try plugging in 1. 4 plus 1 is, over 1 is 5. It's not 4. So it's wrong. It's just simply wrong. So no, don't do that. So the difference between these, what is different between these two? Yeah, Ronnie? One is multiplication, 4 times x. The other is addition. So you can only cancel when it's written as a product or multiplied or factored. Those are all ways of saying the same thing. You must factor first. So the point is factor first always. That would be the main one tip that I could give you for all of these. So now we're gonna do 7 examples. So number 1, well, actually, I'm going to reduce it to 5 because I think you understand that. So let's try, let's start with this one. X plus 5 over 2x plus 10. Okay. Can I just cross out these x's? Nope. Because we have to factor first. So x plus 5 is already factored. But this isn't. So it's going to be great factoring review. What can you take out of 2x plus 10? 2. You can take out a 2. So you write a 2 in front, and then you do the opposite of the distributive property. What times 2 is 2x? X, and what times 2 is 10? Yeah, okay. Now you can cancel something. And you might be wondering, this confuses people. I don't see parentheses around that. Well, you can always add them if it helps you. It's implied. The fact that the x plus 5 is alone on the top like that, you could put parentheses around it. And if that makes it easier for you. And now you are allowed to cancel this and this. That cancels to 1. And the answer is it 2? 1 over 2. That's why you always need 1 as a placeholder. When you have nothing left over, you would need the 1 as a placeholder. So the answer to that is 1/2. Let's try a few more. This cancels to 1, right? So there's a 1, and the 2 is on the bottom. So let's try one that's similar. 5a minus 5 over a squared minus 1. Okay. Do not start canceling things. You have to factor, which is a lovely review of factoring. So let's start with the top. What do you always do when you factor? First step is always to take out the greatest common factor. Is there anything in common with these two that I can take? A 5. So take out a 5. Now do the distributive property backwards. So what goes in parentheses? Good. A minus 1. That's factored. That's done. That's factored. Let's take the bottom. This is going to be an awesome review of a special pattern that you learned in a whole lesson 2 classes ago, which is, yeah, Rupali? First, perfect. It's difference of squares, so it factors to a minus 1 times a plus 1. Because you have two perfect squares and you have the difference. It's called difference of squares, and there's a pattern and a formula that's in your notes from 2 classes ago, and that's factored. Now the fun part is canceling. Whatever is the same on the top and the bottom, that cancels to 1. And your final answer is, yeah, 5 over a plus 1. And you don't need to put the parentheses there. It's implied that parentheses are there. So that is the answer. Let's try this one. Let's try 6x squared. They don't get a whole lot harder than this. Over 2x squared plus 5x minus 12. What would it be tempting to start to cancel out here? The x squareds, right? Or like say that this is 3, you know, you can't do that. You got to factor first, or it won't give you the equivalent expression. So this, when you factor it, there's no greatest common factor, so we go straight to the factored form. When you factor that, you will get 3x plus 1 times 2x minus 3. And I mean, there's several different ways to factor that. That's a separate lesson, but you should be able to factor that trinomial like that. And then if you factor this, you will get, you would use diamonds, or you could use, I forget the name of the other technique, but diamonds, or what is it? Or diamonds and rectangles, or factor by grouping. So you would get 2x minus 3 times x plus 4. So, and if you aren't able to do this, please talk to me as soon as possible, because we have to work together and find the way that works best for you. Now, if nothing was in common on the top and the bottom, you would say, shoot, and you would leave your answer. That would be it. But there is something that happens to be the same, which is, yeah, the 2x minus 3's cancel to 1, and you are left with 3x plus 1 over x plus 4. Yeah, you can leave them with parentheses if you want. And of course, you do not get to cancel these x's here, right? You don't get to. Okay. The last one. Yeah. Times x plus 4. I factored. Should I review factoring? Okay. So if I really quickly to factor this, what method do you want me to use? Grouping or diamonds and rectangles? Okay, well, what I would do is I would say, in my head, I would say, what times what gives you 2x squared? And there's only one possibility, right? 2x and x. And then I would say, what times what gives me 12? 4 and 3. That's one option. It's also 6 and 2, so you have to try different things. And then you check the inner and the outer have to add up to 5x. Negative 3x plus 8x is 5x. Okay, and then the last one. This is going to be funky looking, but it's actually not that bad. 2x squared y cubed minus 8x 4y all over 5x cubed y 4 minus 20x to the 5y squared. It looks awful, but it's actually much easier than it looks. So, equals All right. Can we just start crossing off canceling out the x's and the y's? Nope, because we got a factor. So, what's in common between 2 and 8? Let's find out the GCF first. Yeah, 2. 2 goes into both evenly. How many x's can we take out? X squared, x to the 4? Only 2 of them, x squared. Yeah, you take the smaller exponent. And then y cubed, y, we can only take out y. So we put those on the outside of the parentheses and we do the opposite of the distributive property, but it's great exponent practice. So we're basically dividing this into these and seeing what's left over. So what's left over here? Do you see how it's just y squared? Because I already have a 2, I already have x squared, I need y cubed. Y times y squared is y cubed. So that's it. Minus, what times 2 gives you 8? 4. What times x squared gives you x to the 4? X squared. And what times y gives you y? It's 1, but we don't need to write that. So that's factored. You don't, do we have to do any more work here? We actually can, but we're going to leave it like that for now, because that's actually, now that I'm looking at it, it's difference of squares. So we could go further, but you don't need to. You'll see why. Yeah, Jake. Can you write y right next to, right here, y? Yeah. You can't, because it's already here. And then you would get too many of them. Does that make sense? Yeah, that makes sense. Okay, so now let's take out the GCF here. 5 and 20 is 5, right? X to the 3rd, y to the... Nice. And what's left over using the laws of exponents? Y squared, yeah? Minus 4 x to the... Oh, so convenient. Now, it doesn't always work out that they're the same, and if they're not, you can't cancel them, but nicely they are, because someone made it work out that way. So that cancels to 1. Now, we're left with something that we can actually practice some exponents with, and then we will be done with the notes for today. So we get 2/5 x squared over x cubed y over y squared. Now but we need to make sure it's totally simplified. So we can take that a little bit further, right? What else? Can we simplify 2/5? Nope, so we'll leave the 2/5. What about x squared over x cubed? How many, all right, do you have more on the top or more on the bottom? And how many more on the bottom? 1, so that's it. And then the y's, where do we have more of them? On the bottom. So that's it.